All right, let's talk about one of the most interesting and honestly kind of dangerous features in C#, the dynamic keyword. It's super powerful, really flexible, but it's got this, venomous side. And that's what we're going to dive into today.
So I want you to picture this. Imagine a beautifully crafted perfume. Let's call it Dynamic Poison. It looks amazing, it smells great, and it seems like it's going to solve all your problems with just this incredible elegance. But just one drop in the wrong place, and things can get, well, really unexpected.
Okay, so let's set up the mystery. Take a look at this code snippet right here. If it looks pretty harmless, right? We've got a super simple function, getX, that just takes an integer and gives you an integer back. Nothing fancy. Then, down in our main method, we create a dynamic variable called d. And then we make two more variables, a and b. Both of them are getting their value from that getX function. The only difference is a is explicitly an int, but b is using var. Seems totally straightforward, but this is exactly where our puzzle starts.
So, here's the big question for you. Think about it for a second. The getX function always returns an integer. So what type is the compiler going to guess for b? I mean, the obvious answer is int, right? It has to be. Or does it?
And this right here is where that single drop of poison starts to do its thing, because things are absolutely not what they seem.
Okay, get ready for the twist. If you hover your mouse over A in your IDE, you see exactly what you'd expect. It's an int. No surprise there. But then you look at B, and what? The compiler says it's dynamic. How is that even possible? We know the function returns an integer. It says so right in the signature. This is the heart of our whole mystery.
So, to crack this case, we have to unmask our prime suspect. What exactly is this dynamic keyword? And what are its motives? How does it even work?
Okay, so here's the deal with dynamic. It's basically a special note you leave for the C# compiler. It's like you're telling it, hey compiler, see this variable? Just trust me, don't check its type right now. It'll all work out, I promise. We'll figure it out when the program is actually running. So yeah, all those safety checks get pushed to runtime.
You know, C# is normally a statically typed language. Think of the compiler as a really strict bouncer at a club. It checks everyone's ID, their type, before it lets anything run. But dynamic? That's the ultimate VIP pass. It lets your variable just waltz right past that bouncer, no questions asked. The check only happens later, on the dance floor, as the code is executing.
And you know, Eric Lippert, who's one of the geniuses who worked on the C# compiler, came up with the perfect way to think about this. He said, dynamic is just object wearing a funny hat. And that's brilliant, because underneath, it's really just a plain old system.object, but it's wearing this special hat that signals to the compiler, hey, treat this one differently. We're doing things at runtime here.
And here's the proof, right in the code. We've got an object holding the number 5 and a dynamic variable holding the exact same number. And look what happens when we ask them for their type at runtime using getType. They're identical. Both of them are actually an int32. That dynamic keyword, it's just a message for the compiler. Once the code is running, it's just an object like any other.
Okay, so now we know who our suspect is. The next question is, how does it commit the crime? How does this so-called poison actually spread through your code?
Well, the rule is surprisingly simple, but it's also incredibly consistent. Here it is. If any part of an expression is dynamic, the compiler just goes, okay, the whole thing is dynamic now. The entire result of that expression becomes dynamic. It's infectious.
And that right there brings us right back to our original code mystery. Look at that line. var b equals getX of d. Remember, our argument, d, is dynamic. So because of this poisoning rule, the compiler sees that dynamic and treats the entire function call, the whole getX of d expression, as dynamic. The result gets infected, and that is exactly why var b ends up being dynamic.
All right, so we get the problem now. It's a really cool piece of compiler logic for sure, but in our day-to-day coding, we need to know how to control this stuff. So what's the antidote? How do we stop the poison from spreading?
And here it is. The antidote is actually super simple. You just use an explicit cast. Look at this code. By casting our dynamic variable d back to an int before we pass it to the function, we completely remove the poison from the equation. And you can see the new variable x is now correctly inferred as an int. Problem solved.
So the whole procedure is just 2 easy steps. Step 1, find the dynamic variable that's causing all the trouble. Step 2, slap an explicit cast on it. You're basically telling the compiler, hey, chill out. I know this looks dynamic, but I'm telling you right now it's an int.
That's it. The infection is broken, and you're back in the safe world of static typing. Okay, so we figured out the what and the how, but the last piece of the puzzle is the why. Why on earth is the C# compiler designed to work this way? What's the motive behind this whole poisoning effect?
Well, the simplest answer is the compiler is just a good soldier following orders. It's not trying to trick you or be clever. It's just obediently following a fundamental design principle of the language. And that core principle is this. If you ask for dynamic binding, then you get dynamic binding. When you use dynamic, you are very clearly telling the compiler, I want to opt out of compile time checks for this operation. And the compiler respects that. It honors your request by making sure the entire result stays dynamic. It's not a bug, it's a feature designed to preserve your intent.
And this brings us all the way back around to that brilliant funny hat metaphor. That dynamic keyword, that's the funny hat. It's the signal. As soon as the compiler sees it, it knows to switch gears from its usual static checking to dynamic mode. And this whole poisoning thing, that's just the compiler making sure that anyone who talks to the guy in the funny hat gets treated as part of the same dynamic part.
So there you have it. The dynamic poison has been unmasked. And we can see it's not a bug or a flaw at all. It's a really powerful feature that just plays by a very specific set of rules. It's an elegant tool, for sure, but now that you know its secrets, you also know the antidote. So the only question left is, how are you going to handle it in your own code?